Highly complex systems are inherently fragile. A massive physical structure can completely collapse from a single tiny point of failure. For the physical universe, the ultimate metric of risk is a seemingly random number, 0.00729735, more commonly expressed as 1 over 137. This constant has a strict function. It dictates the exact strength of the electromagnetic force across the entire universe. The cosmic margin of error is extremely narrow. If this constant increases by just 4%, electrons bind so tightly to their nuclei that chemical bonding becomes impossible. If it decreases by 4%, atomic structures dissolve, electrons drift away, and stars cannot fuse carbon. All of chemistry, biology, and stellar physics exists entirely because reality balances precisely within this unexplained 4% margin. Physicists have mathematical equations to map almost every mechanism in the universe. Yet there is absolutely no theoretical framework that predicts why 1/137 is the universal baseline. Richard Feynman spent his life analyzing it, pointing out that it is one of the greatest damn mysteries of physics. Wolfgang Pauli shared that fixation, famously claiming his first question to the devil after death would be demanding the meaning of the fine structure constant. Pauli Dirac classified it as the most severe unsolved problem in physics. The founders of quantum mechanics carried a shared existential dread regarding this number. A universe built on logical, elegant mathematics relies on a perfectly tuned master number with no discernible origin. The investigation began in the late 19th and early 20th centuries, a period when scientists first gained the technology to audit the atomic world with high precision. Albert Michelson initiated this by taking highly precise measurements of the light spectrum emitted by hydrogen atoms. This spectrum chart displays the expected light emission of a hydrogen atom. The baseline assumption was that when atoms shift energy levels, they emit photons at a singular wavelength of light, creating one clean line. As measurement tools improved, a discrepancy emerged. What appeared to be a single spectral line was actually a pair of nearly identical lines, separated by a microscopic gap. German physicist Arnold Sommerfeld observed that the energy difference between these split lines was always a multiple of one specific mathematical ratio. A tiny accounting error in the light spectrum forced physicists to uncover the fine structure constant, the hidden mathematical metric governing the atom. Sommerfeld's resulting equation combined the electric charge of an electron, the speed of light, and Planck's constant into a single formula. Standard physics equations rely on human-defined units to represent physical relationships. We measure things in coulombs, meters per second, and joules. This formula reveals a mathematical anomaly. When these specific fundamental constants are combined, all of their human-invented units mathematically cancel each other out. The process leaves behind a pure, dimensionless number, which resolves to exactly 1 over 137. Functionally, this number acts as a coupling strength. It represents the exact base probability that an electron will interact with a photon. The constant scales with energy. During the extreme heat of the Big Bang, this coupling strength was massive, measuring closer to 1. But as the universe cooled, it flatlined perfectly at 1 over 137. It is the universal exchange rate that dictates exactly how light and matter interact at the absolute lowest levels of reality. Standard physical constants require human context. A measurement like 300,000 kilometers per second for the speed of light is completely meaningless if you don't use kilometers and seconds. Because 1/137th is completely devoid of units, its value is objectively true anywhere in the universe, independent of any human perspective or invention. Consider a theoretical scenario where we attempt to broadcast a short radio message to an alien civilization to prove we are an advanced, intelligent species. Broadcasting normal physics has a major flaw. Sending the gravitational constant would require teaching the aliens our arbitrary Earth-based concepts of kilograms and meters. Broadcasting the raw ratio of 137 in binary acts as undeniable proof of intelligence because it speaks the native, fundamental code of reality itself. The final unresolved question facing modern astrophysics is whether this ratio varies. If this metric holds the universe together, has it always been exactly 137, or does it fluctuate across time and space? Teams of scientists are currently analyzing the light from ancient quasars to measure what the fine structure constant was 10 to 12 billion years ago. A 1999 study presented controversial findings, detecting a microscopic discrepancy suggesting the constant may have been lower in the deep past. But this deep space data is fiercely debated. Many physicists dismiss the anomaly as mere signal noise, leaving the variance unproven. Regardless of a slight historical variance, it remains the literal mathematical glue, sitting exactly within its razor-thin margin to allow for our existence. Until physicists can decode why the universe selected this precise metric, our understanding of reality and our own origins remains completely incomplete.